We're going to represent a linear equation using a table, and this is an example of a linear relationship that is non-proportional. You may recall from some of our earlier videos that a proportional relationship is one that can be represented using the equation y equals kx, where k is the constant of proportionality, or sometimes we say it's represented using y equals mx plus b, where b equals 0. And what this means is that the equation does not pass through the origin, does not pass through the coordinate 0, 0. That's what we mean when we say a non-proportional relationship. It does not pass through 0, 0. A proportional relationship does pass through 0, 0. And we can tell from the first sentence of this problem that this is a non-proportional relationship that will not pass through 0, 0 because it says the equation y equals 3x plus 2. Well, stopping right there, y equals 3x plus 2, that plus 2 tells us it's non-proportional. It's going to pass through a point besides 0, 0 on the y-axis. So let's finish reading. It says the equation y equals 3x plus 2 gives the total charge, y, for bowling x games at Baxter Bowling Lanes based on the prices shown. Make a table of values for the situation. So the prices shown, as we can see from the graphic, are that each game costs $3 and then a shoe rental is $2. So every game we play is going to cost $3. The shoe rental is $2, and of course you only rent shoes one time, and then you pay $3 for every game after that. So the $2 shoe rental happens just the first time we play, and then you add $3 for every game played after that. So making a table to represent this really requires us to do two things. We're going to start off with just making the XY table. Remember, according to the problem, X is the number of games. It says bowling X games. And then Y is the total charge. So the first thing we want to do is we want to fill in the X part of the table with some numbers that make sense. Now, when I say make sense, I mean we're not going to put, for example, a negative number in for X. We are not going to put -3 for X because it would not make sense for us to bowl -3 games. We also are not going to put in a decimal like 1.2 or a fraction like 1.5 because it wouldn't make sense for us to bowl 1.2 games or 1.5 games. We're also not going to put in 0. Bowling 0 games, although it would be useful if we were going to graph this to have the point x equals 0 on our graph, it doesn't make sense to bowl 0 games because that would mean we show up to the bowling alley, rent the shoes, and then just sit around in bowling shoes. That does not make sense either. We're going to bowl at least one game. So it might make sense to have the x value of 1 there. And then we'll just do like, let's say 2, 3, 4, and 5. This is going to represent we bowl 1 game, 2 game, 3 games, etc. So then what would the value of y be for each one of these? And so we could use a calculator to solve these. The math here is pretty simple. What we're going to do is take that equation, y equals 3x plus 2, and we're going to replace the x 5 times, once with each one of these values of x that we've chosen. So for example, we could do y equals 3, and then the first value of x that we chose was x equals 1 for bowling one game. So we would substitute 1 in place of x. And so in our calculator, we would type 3 times 1 plus 2. 3 times 1 is 3. 3 plus 2 is 5. So what this tells us is if we're going to bowl one game, it's going to cost us $5. And that's because we pay $2 for the shoes and then $3 for the game. Okay, great. Our next value of x was an x value of 2. So we would do 3 times 2, 2 games of bowling plus 2. So we pay $2 for the shoes and then $3 each for our 2 games. So in the calculator, we would type 3 times 2 plus 2. 3 times 2 is 6. 6 plus 2 is 8. So 2 games of bowling would cost us $8. $2 for the shoes, $6 for the games, for a total of 8. Next, we have 3. So our total cost is 3 multiplied by 3 games of bowling plus the $2 shoe rental. 3 times 3 is 9, plus 2 is 11, so 3 games would cost us $11. $2 for the shoes and $9 for our 3 games. We could continue to plug in 4 and 5 into our equation to get these last two missing values, but maybe you're seeing a pattern. And the pattern that you might be seeing is that we are adding 3 every time the x increases by 1. 5 plus 3 is 8. 8 plus 3 is 11. So if we add one more bowling game, if we go from 3 games to 4 games, it would make sense that we would add $3 more for our one additional game. 11 plus 3 is 14. And in fact, we could check this with the calculator by doing y equals 3 times 4 plus 2, which it will come as no surprise to you is in fact 14. $14 for 4 games of bowling. And then if we take 14 and add 3 to that, we will get the cost for 5 games of bowling. 14 plus 3 is $17. And again, if we were really nervous that we weren't doing this correctly, we could check that on the calculator as well. 3 multiplied by 5 games plus 2. 3 times 5 is 15, and 15 plus 2 is 17. And so now we have managed to make a table to represent the cost for our first 5 games of bowling if each game costs $3 and there is a $2 shoot rental fee.